because you could learn about astronauts and different kinds of animals. I like the space exhibits. I like to work with rocks, different kinds of rocks.
Science is important because you can learn new things and you'll just be smarter.
T-minus 10, 9. We have a go for engine start. 6, 4, 3, 2, 1. Ignition and liftoff of Columbia in the first dedicated medical research flight.
Hi, my name is Millie Hughes Fulford, and I rode that rocket. As a NASA scientist astronaut, I spent 9 days in space aboard the shuttle Columbia. My mission was Space Lab Life Sciences 1. Our job was to study how life in space affects the human body. When I was a Girl Scout back in Mineral Wells, Texas, I wanted to go into space. But as I got older, I realized that all the astronauts were male test pilots. In those days, women weren't encouraged to do things like that. Women didn't become jet pilots or go to work for NASA. Not too many of us went into math or science either. But today we do all those things. I'm lucky. As a young girl, I loved to explore and experiment and discover new things about how the world works. Girl Scouting taught me that I could plan my future by setting goals and working hard. Girl Scouting taught me new skills, how to work in a team, and it taught me leadership. That's why I'm so glad to be able to speak to you. I loved Girl Scouting when I was young. It opened up new worlds for me, and it can do the same thing for young girls today.
Roger, roll, Columbia.
You know, going into space starts with a good education by learning the fundamentals. That's why Del McCready, the director of the National Science Partnership for Girl Scouts and Science Museums, is here today. She has developed some great activities that you and your Brownie Girl Scouts will really enjoy.
Hi, Millie.
Hi, Del. What do we plan to do today?
We're going to be doing some astronomy activities. We've developed activity kits, like the Space Explorer kit, that are directly linked to the Girl Scout recognitions. When your troop completes the Space Explorer kit, the girls will earn their science recognition. And we offer special trainings for leaders, too. At these workshops, you'll learn what to do to make science fun and exciting for your girls.
Do the leaders ever express concern about being able to teach science?
Some leaders do feel concerned. They're afraid that they'll get questions that they don't know how to answer, or that the girls just won't be interested. Sometimes the leaders don't have a very good feeling about science either. So hopefully, when you leave this workshop, you'll feel positive about science and the excitement it can bring to your troop.
I'm sure they will, and it's about time for our first activity, but my watch has stopped.
Wonderful. We're about to build a sundial, so we'll help you set your watch. Come on back.
Even before the first clock was built, people could tell time by the location of the sun.
Hi, girls. We're going to do some activities today with the sun and with shadows. Who can tell me what a shadow is? Lisanne?
A shadow that black and then the sun block it and then it make a shadow.
Okay, something blocks the sunlight. Did anyone notice where the sun was this morning when we got here? Over there? That's right. Okay, let's stand up, and what I'd like you to do is everyone point with their right arm towards where they saw the sun earlier this morning. Their right arm. Sherry? Let's turn around. That's your left arm. Okay, there you go, your right arm. Now that's the east. Now put your left arm out. That's the west. Who knows where we're facing?
North.
North, that's right. Keep that in mind, and we're going to sit down. And we're going to talk today about sundials. Now, we made this very simple sundial earlier. Who can tell me how the shadows changed since we worked on this earlier? Becky?
Shorter.
It's shorter, that's right. What's been happening? What's the Earth been doing all day? Sherry?
Going around in circles.
Going around in circles, that's right. It's been rotating. Now, when is it that we don't have any sun? Lisanne?
At night?
At night, that's right. So there is a time when we can't really use a sundial because there's no sun. Keep in mind now where we found north. Now what I want you to do is set up your sundial and have it pointing towards north. You also have a compass, and those of you with compasses, I'd like you to check and make sure the sundial's pointing north. Who can tell me what a compass does? Whitney?
It tells you which way to go, north, east, south, and west.
That's right. Okay, let's set up your sundial and point it towards north. Can you see the shadow?
Yes.
What time is it?
2 o'clock!
All right. Good job. That'll help Millie fix her watch.
This is the Franklin Institute Science Museum in Philadelphia, one of the oldest hands-on science museums in the nation. The National Science Partnership began when the Franklin Institute joined with 2 local Girl Scout councils to help teach the girls hands-on science. In 1993, the Franklin Institute, with the Girl Scouts of the USA, received their second National Science Foundation grant that will expand the program nationwide. Hi, Dale.
Hi, Millie.
Why don't you tell us why it's so important to have hands-on science?
Sure. Hands-on science is fun, and the girls love it. People learn so much more when they're actively involved. There's a quote that we use here at the Franklin Institute because we're a hands-on science museum. And it goes something like this. It's tell me, I will forget, show me, I will remember, and involve me, and I will understand.
What do you think the most important thing for the Brownie Girl Scout leaders to know about science?
The most important thing you can do as leaders is to encourage your girls to ask questions. Questions are more important than answers in encouraging the process of science. And be sure to let them do the discovering. Don't tell them the answer. And last but not least, don't forget to have fun.
That's right. You learn a lot more when you're having fun. So sit back, relax, and enjoy the next activity. I know we're going to. Did you know that when I was in space, I got to see the phases of the Earth? You'll understand why at the end of the next activity.
So today we're going to be talking a little bit about the moon and the earth. And what I was wondering is if anyone's taken any time to look up into the sky lately and has noticed anything about the moon.
The moon has cradles and it goes around and around.
The moon has craters and it goes around and around. What's the moon going around? The Earth. And what else have you noticed?
Different colors.
It's different colors. Why does the moon have light?
Because of the sun.
Because of the sun. That's right. It reflects the light from the sun.
Why does it change shape?
Why does it change shape? What a perfect question. That's a really good question. Moonlight is actually light from the sun, reflected off the surface of the moon. On Earth, we always see the same side of the moon, but as the moon orbits around the Earth, we see different portions of the illuminated surface. The moon appears to change shape as a result of its position relative to the Earth and the sun. These changes are called the phases of the moon. It takes about 28 days for a complete cycle of the phases, as the moon goes from new moon, when the illuminated side is not visible, to first quarter, to full moon, to third quarter, and back to new moon. The terms first quarter and third quarter refer to the location of the moon in its journey around the Earth. Well, we're going to do an activity now, and I'm going to set you up so that we can look and see what causes the moon to change shape. And I'm going to give you each a tennis ball and a flashlight. And the person holding the flashlight, we're going to call you the sun brownie. And the person holding the tennis ball, we're going to call you the earth brownie. Those of you with tennis balls, I want you to face the person with the flashlight. And those of you with the flashlight, I'd like you to shine your flashlight on the tennis ball. What does the tennis ball look like now? Can you see some light on the ball?
Yes, the whole thing.
That whole thing. Okay, that's what a full moon is. Now I want those of you with the tennis ball to turn one quarter turn to the left. Now look at your tennis ball. What do you see?
Well, it's only this part.
It's only that part. It's only a half moon, right? What they actually call a quarter moon. Okay, now turn away from the flashlight, away from the sun, and put the ball above so that the sun can hit it there. And now what?
A whole moon.
A whole moon. Now go around the other way. A half moon, and now back towards the sunlight again. It's dark, isn't it? So now that we've done this activity, Hopefully you all understand what causes the phases of the moon. Not only does the moon's shape appear to change, but the time of day that the moon is visible changes as well. Near the first quarter, the moon is visible in the afternoon. A full moon rises at sunset and sets at sunrise. The third quarter is visible between midnight and noon, and a new moon is not visible at all. Now what I'd like to do is 3 of you have shirts. Now if you could put on your shirts, we'll set up for this activity. Okay, now we have the Earth, the Sun, and the Moon. Does anyone know how long it takes for the moon to go all the way around the Earth?
A month?
A month, exactly. And how fast does the Earth rotate?
Once a day.
That's right. And how long does it take the Earth to revolve around the Sun?
A year?
A year. And now we've got to make you 3 all do that. Now let's put you sun brownie here. You get to sit here and just radiate sun, okay? Just practice your radiating. Okay, there you go. You're radiating sun. You 2 have to move around each other like this. You can walk full step. Okay? Like that. And you're going to turn really slowly, but you're going to also try and move in a circle around the sun brownie. And you're going to move all around her. That's right. That's right. You got it. You got it. Now you keep rotating and revolving. There you go. Now keep doing that around the sun, and you start radiating. Now keep going all the way around. Let's give these girls a hand. Yay! Good job. Didn't know sitting here on Earth was such a complicated thing, did you? So now that we understand the phases of the moon, how many of you think you'll go outside tonight and observe the night sky? Great.
That was great, Dale. I'm sure that everyone understands about the phases of the Earth now, too. The sun's light reflects off the Earth, just as it does off the moon. That's why you can see the Earth from space, even though it doesn't generate light of its own. You can't see all of it, though. The part that's turned away from the sun will be in shadow, just like the moon is when we look at it from Earth.
The full Earth, the half Earth, the new Earth, that must be a spectacular sight.
It really is. The Earth is so beautiful. When you look out the window, you see a black void and then the Earth right there. And it's like a fragile crystal ball, and you feel responsible for it, and you want to reach out and take care of it. When you're off the planet and you look on the Earth, you see it in an entirely different light. And speaking of light, did you know that what we call white light isn't really white at all? If you split up that light, you'll see every color in the rainbow. In fact, that is how a rainbow is made. When raindrops fall through the sunlight, they split that light into colors. The colors shine out in bands, and if you and the sun are just at the right angle, you'll have a rainbow. Spectroscopes are instruments that can separate light into different colors and identify those colors as different wavelengths. Astronomers will use a spectroscope to study the light from distant stars, but we can study different kinds of light right here on Earth. We're surrounded by different kinds of light: neon lights, fluorescent lights, even sunlight. Each type of light has its own spectrum or signature, and with a spectroscope, we can identify its spectrum and its wavelengths.
Hi, everybody.
Hi.
Today we're going to do an activity to understand what an astronomer does. Who knows what an astronomer is?
It's a person who studies the sky.
That's right.
A person that studies the moons and stars.
And a person that studies the moon and stars. Who can tell me what might be a good tool to use, a good instrument to use to look out into the sky?
A telescope.
The telescope. A telescope is one. The spectroscope is also something you look through, and that's what we're going to build today. Now, a spectroscope is an instrument that analyzes and examines light. It'll make light turn into all of its different colors. So now what I'd like you to do is open up your toothpaste boxes and at both ends. Okay, now each tongue is going to be a little bit different. One tongue is going to have a hole in it, and one tongue is going to have a cut in it. Okay, so I want one of you to have scissors and one of you to have a hole punch. You're going to slide the hole punch over and cut through the tongue and the black piece of paper. Would you like me to help you? Yeah. Okay, there you go. Now turn it around and go to the other end and find that tongue. And now what I'd like you to do is cut a really thin slit from the very tip of the tongue all the way to where it joins the box. By cutting narrow slits into the ends of the boxes, we limit the amount of light that enters the box and falls on the diffraction grating. Diffraction means to separate into parts. What we use are small pieces of plastic that have many grooves scratched into it. The grooves work like a prism, separating light into its spectrum or component colors. See anything happening to the light when you look through it?
Yeah, a rainbow. It's like
You see a rainbow. That's exactly right. What color does light usually look?
red.
Now, without this.
Yellow.
Well, do you know that light is actually made up of a lot of different colors? A lot of different colors make up light. Who might know what the colors of the rainbow are?
I know because my science teacher told me a name that's Roy G. Biv. And red is for, R is for red, O is for orange, Y is for yellow, J is for green. Y is for yellow. B is for blue, I is for indigo, and V is for violet.
Violet, there you go, Roy G. Biv. R-O-Y, Roy, G, like an initial, Biv, B-I-V, Roy G. Biv. So we're going to put these little pieces of plastic, the diffraction grating, into our spectroscope so that we can use it to split light so that it actually shows light patterns. It'll make light turn into all of its different colors. As light enters the slit, it passes through the box to the diffraction grating, where it is split into its spectrum. If an everyday light bulb is viewed through a spectroscope, the pattern will appear like a rainbow, a continuous display of all the colors. However, if a spectroscope is used to view a gas street light, only certain bands of color will be visible. Every star has a different pattern. By comparing the bands of known chemicals here on Earth, it's possible to determine the temperature and chemical composition of stars. And what you're going to do is look through the little hole with the piece of diffraction grating, and light is going to come through your slit. So what I'd like you to do is hold up your boxes, look directly at one of these very, very bright lights.
Oh, I just saw a rainbow.
You see a rainbow?
I just saw a rainbow.
What does it look like?
It's like a bottom line.
What would you recommend doing with your troop?
Well, what's been helpful for me is to bring one perhaps already done ahead of time or in different stages, one that's already complete, halfway complete, and also breaking the girls up into pairs the way you did in the buddy system. Lets them have an opportunity to share, and they can also learn to wait, but they can also assist somebody. And there's some cutters that cut better and some people who punch holes better. So then it makes it a much more enjoyable experience for everybody. Who had fun today?
How do you feel about doing hands-on science with your troop?
I'm willing to try some more. I mean, that ended up being pretty good. The girls enjoyed it and I enjoyed it. It wasn't as difficult as I thought. But they asked a lot of questions.
One of the things that leaders feel most uncomfortable with is the fear that they'll get a lot of questions that they don't know the answer to. It's okay not to know the answer. It's really all right to say, I don't know. We can't be expected to know everything. And in fact, it's more encouraging for the girls if you aren't the authority on everything.
Is there additional training I can get, though, just in case some of those questions come up? I'd kind of like to have a little bit better knowledge base about some of the different concepts with science.
One of the things we've done with the activities is that each activity has a description of what to do, and it has a section called Whys and Hows. And in that content area, we've given you most of the basic information. This will give you a starting point and it'll give you content. You also should know that there's a lot of other resources around. In this partnership between science museums and Girl Scout councils, there's always science expertise at the Science Museum.
That makes me feel a lot better.
Thrust is the force which propels a rocket. The fuel in a rocket must provide enough energy to develop the speed required to escape the pull of Earth's gravity. The propellant, once ignited, produces gases which thrust the rocket forward in the opposite direction of the outrushing gases. Isaac Newton described 3 laws of motion. The third, for every action there is an equal and opposite reaction, applies to the blast-off of a rocket. Millie, I'm so glad you could be here for the rocket launch today.
You know me, I would miss a rocket launch for the world. In fact, I wouldn't miss any of these activities. Have you had a lot of response from the Girl Scout leaders that have taken the workshop?
We have, and they've been really thrilled and excited about the program. Leaders leave the workshops eager to do hands-on science with their girls and encourage that it's okay not to know all the answers.
Girl Scouting offers a very unique environment for the girls.
It sure does. Girl Scouting is a place where girls can work and learn together. The setting's informal, non-threatening, and fun. And the girls don't feel some of the inhibitions that sometimes occur when boys are around.
I know I grew a lot during my years in Girl Scouting. It helped me learn to set specific goals and to work toward them. And it helped me become the person I am today.
Let's go set off a rocket.
Let's do it.
How are you all doing? Fine. Setting up your rocket? Millie, you know, was out in a rocket. What I wanted to do was talk to you a little bit about how rockets work. Have any of you ever set off a rocket before?
No.
It's really not very dangerous if you follow all the safety rules. And so we're going to be very careful to go through what's important to do and to be very safe. And then we're going to get to see what a real rocket launch looks like. Now there's a few steps that we need to do for pre-flight. The first thing is we use these pieces of paper that you've rolled into a ball. This is called wadding. This wadding is something that is flame resistant. What do you think that means?
Can't catch on fire.
That's right, it can't catch on fire. And so what we want to do is be sure to put the wadding into the tube of the rocket. So I've put one in. Let me ask you to put in another one, and then this one. There we go. So that's called the wadding. That's the first thing you do when you're setting off a rocket. You put that in so that when the engine explodes, then you don't get the rest of the rocket catching on fire. The next thing we do is we fold the streamer. This is something that will just help us see where the rocket is so that when it's coming down, we'll be able to see it. Now what's going to happen is we're going to insert an engine here, and then we need to put some fuses in, something that actually causes the rocket to go off. So it's just going to have a little explosion and it's going to go up. And when it gets up to the top, the cone is going to come flying out and the streamer is going to come out so you can see it. And now what we want to do is we put the engine in and we're going to put this fuse in. Now the trick to the fuse is you want to stick the end of the fuse all the way into the hole till it stops and then put this little orange tab in. So who's got really little fingers? Here, let's see. Can you hold on to that little orange tab? And I'm going to hold the igniter in and you put that in there. That's right. Good job. Okay, now that holds the igniter in there towards the engine. Now what we're going to do is set the rocket for takeoff. Sherry, how about if you take a hold of the little orange cap there and you hold on to that because that's the key that's going to set off our rocket. You go ahead and take it off. Jamie, why don't you slide this on now? What you want to do is there's two little hooks there. Slide it right onto the rod and put it all the way down to the bottom. You see how it goes? So now we want to make sure we put the cap right back on until we're all ready to shoot the rocket. Because you never know when someone could fall, so you want to make sure that that's protected. Everyone has to stand all the way back. Let's go that direction. And Lisan, if you could pull back until this is tight. Okay, there you go. Now here's the rule, no one steps any closer than that yellow controller. Now the important thing here is that these two clamps shouldn't touch each other because when you actually turn, when we push that button, that could end up short-circuiting and nothing will happen. The rocket will just stay here. So we just want to make sure we've done that all right. So have we done everything you can think of that's safe? Okay, now the one thing we have to do is make sure to take this off because not only will the rocket not shoot off with the cap, but we need the key. Now the next thing we're going to need is we're going to need some counters. We need you all to count together. You start counting down from 10, and when we hit 5, I'm going to put the key in, and when they say blast off, you push the button, okay?
Ready? Be ready to watch it because it's going to go fast. Ready? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off! Whoa!
Where is it?
There it is, look. You can see it coming down. See the streamer?
Look at it.
Where's it going?
Here
Go get it! Uh-oh! Where'd it go?
It's in the tree.
Go see it. Go see if you can get it.
I hope you've enjoyed these demonstrations as much as I have. I'm really excited about how much fun they are and how much you can learn from each of them and how inspired your Brownie Girl Scouts are going to be when they find out that they can do science. A science education doesn't start in college. It begins in early childhood when we discover the joys and the satisfactions of asking questions and finding the answers. It begins with a curiosity about how the world around us works. A curiosity all children feel, but that too often is stifled in our young girls. As a Brownie Girl Scout leader, you can help the girls in your troop develop or even recapture that curiosity. And who knows, maybe someday one of the girls you lead will grow up to be a research scientist or a jet pilot, an astronaut, or even a president. The sky's the limit for women today, as long as we set goals, work hard, and believe in ourselves. And you have a precious opportunity to help your Brownie Girl Scouts do just that. Believe in themselves, enjoy themselves, and learn to grow strong in the knowledge that they can do anything they set their minds to do. You can help them reach for the stars.
I want to be an astronaut. I want to be a nurse. I want to be a scientist.